from homeworks. Jacob.
Could you do number 4, the homework 3-5?
Sure. Today's the 7th. Homework 5, and you said number 4?
Yes, please.
Okay.
Can I turn the lights off?
Absolutely. All right. So Jacob, I'm going to ask you some questions because I want to do this problem the same way that you attempted it, so you get the most out of seeing me do things. Is that okay?
Yeah.
Okay. So we'll call these three equations A, B, and C. Which variable did you try, or did you do this using substitution or elimination? I guess that's the first question.
I'm not really sure,
Okay.
but I think the Z variable is first.
Okay, so elimination, it sounds like what you were trying to do. And you're going to eliminate Z's. Okay, sounds good. And how did you try to eliminate the Z's?
So what I did was put Z on one side.
Okay, so you are using a substitution then. Okay. Okay, so which equation did you try to do that with? A. Okay. So I wouldn't do that as a recommendation because when you have to divide by -3 to get the Z by itself, you're going to create a whole bunch of fractions, right?
Yeah. So you C first.
Yeah, what if we did this one? Because here we can just add the 6x to both sides and the 4y to both sides to get the Z by itself, and then there's no fraction going on. And again, not that what you're trying to do before was incorrect, but it was going to be inconvenient. You know what I mean? So now I'm going to take this value for Z and plug it into equation A and plug it into equation B. So I have -3x minus y minus 3, but instead of Z, I'm going to write 6x plus 4y minus 20. And then I still have the equals -8. I have 5x plus 3y plus 6, but instead of writing the Z, I'm going to write 6x plus 4y minus 20 equals -4. Does that feel okay so far?
Yeah.
Okay. So let's distribute now through and combine some like terms. So this -3 is going to distribute through here. And then -3x and -18x give me -21x. -1y and -12y give me -13y. And then I'll just subtract that 60 to the other side. And we'll do the same thing with the other equation now. So distribute that 6 through. And then we'll combine the x's, so -5x and 36x give us 31x. 3y and 24y give us 27y. And then I'll add that 120 over to the other side to get 116. This now becomes our new system of equations. Oops. So I'll recopy those. So far, so good, Jacob? Okay. So what variable do you want to work on next?
The Y.
Okay. So which equation are you going to use? You used equation, I'm sorry, I couldn't, we'll call these D and E. Which one?
I use
E, okay. So to get the y by itself, we subtracted the 31 over and then divided by 27. Oops, that's supposed to be an x though. And now we'll plug that into equation D. And so I'll have 21 or negative 21x minus 13. And then instead of y, we'll write this. So now we need to distribute things through. So 13 times 31 is 403. And 13 times 116, that gives me negative 1508 over 27. Now, eventually I'm going to have to add 403 over 27x plus 21x, so I need to make a common denominator. So I'll multiply the top and bottom of 27 or negative 21x by 27 over 27. So it's going to give me negative 567 over 27. And similarly, I'll do the same thing with the negative 68 because eventually I have to add that 1508 over 27 to it. Okay with that, Jacob?
Yep.
Okay. And then we'll combine our like terms. So that's negative 164 over 27 equals, and then I'll add the 1508 over. It's negative 328 over 27. And now to solve for x, I'll multiply by the reciprocal. And so I get x is equal to 2. So that's one part of our answer. To get the next part, we're going to go ahead and plug this back into our equation for y. So 2 times negative 31 over 27 is negative 62 over 27. And negative 62 plus 116 is 54. And that reduces down to 2. And now that we have these, we're going to go and plug them back in here for z. So I get 12 plus 8 minus 20, which is 0. So our answer Okay with that, Jacob? So substitution works, but you notice that we encountered a lot of fractions in doing that. That's pretty typical of using substitution. Elimination, you typically don't have to run into any fractions. Just kind of comparing and contrasting the two methods. It doesn't matter to me on these 3 variable ones which way you do it. But if you are anti-fraction, I would stay away from substitution if that makes a difference. If you don't care, then don't worry about it. But the fact we ran into quite a bit of fractions here and had quite a bit to deal with is pretty typical of substitution. Who's next? Joe?
On homework 2, chapter 3, homework 2.
Mm-hmm.
Can you do number 3, please?
Sure. Okay. So if we look at 3, it seems a little odd because neither of the equations have both x's and y's in it, right? That's okay. What you probably didn't remember from your previous algebra class is that an equation with y in it only means that you're talking about a horizontal line, and x only means we're talking about a vertical line. So the question only then becomes like, okay, where does that what point does that horizontal line need to go through, that vertical line needs to go through? In the case of y equals 4, it just has to go through the y coordinate of 4. Now the x, we need to get the x by itself, so when we divide by -2, the inequality symbol flips, and we're left with -3 on the right side. So my vertical line needs to go through the x coordinate of -3. So there's that. Okay with that? Okay. So y greater than 4, well, the y coordinates that are bigger than 4 are all up above the line. And x less than -3, all the x's that are less than -3 are on the left side of the line. So our solution here is that little square there in the corner.
Perfect. Makes sense.
Good. So again, this was the remembering that key from Algebra 1 or geometry. You probably talked about it even last year in geometry, but it's easy to kind of forget what to do with that. But that's the gist of it. Who's next? Okay. That's fine. Oh, yes, Megan. I guess I didn't see you. Sure. Okay. Megan, did you do substitution or elimination? Okay. And which variable did you try to eliminate first? The y's. Okay. And how did you do that? Okay. And what did you add it to? B. Okay. And then what else did we do? Yup. Yep, that's correct. That all sounds good. So 2 times a, I have 2x minus 2y minus 4z equals negative 12. And then b, I'll just recopy down. Notice that there's no z, so I'll just write like a 0z there, just so everything stays lined up for me. So if I do that, I get 5z, or 5x. The y's cancel out. Minus 4z is equal to negative 37. And then if I do a plus c, I'm not going to rewrite a and c since we didn't change them at all. I'm just going to look at the equation. So 1x and negative 4x is negative 3x. Negative 1y and positive 1y is 0y. Negative 2z and negative 1z is negative 3z. And negative 6 plus 12 is positive 6. So those are going to become my new system. So far, so good, Megan? Okay. What variables do you want to eliminate now? Yeah, it doesn't really matter, right? So we'll get rid of the z's, okay? And how are we going to do that? Okay. I agree with that. That'll work. So 3 times d, 3 times 5 is 15. 3 times negative 4 is negative 12. And 3 times negative 37 is too early for me to do that in my head. That's negative 111. Then I have negative 4 times negative 3 is positive 12. Negative 4 times positive 3 is positive 12. And negative 4 times positive 6 is negative 24. So 12 and 15 is 37x. 111 and 24 is 135. And something's wrong, huh? Oh, yeah, it is. That's more like it. Thank you. Woo! So when I divide both sides by 27, I get x equals negative 5. And now we'll just substitute this back into either d or e to find z. For the sake of argument, let's plug it into e. The numbers are a little bit smaller, so that would be my choice. So that gives me z equals 3. We good with that, Megan? And then to get y, we'll plug these back into either spot. I'm going to choose to do equation B, because notice that I don't even need the z for that one. So if I add the 15 over, 2y is equal to 10. And if I divide by 2, I get y equals 5. Oops. That should be 2y equals negative 10. So that should be negative 5. Sorry about that. Does that feel okay, Megan? Just as a heads up here, what the decisions you made were perfectly fine. There's no problem with it. You could have made this a little bit shorter by eliminating the z's because you already have one equation with no z in it. So in that first step, if you just eliminated the z's from A and C, you could have kept equation B and then just done one elimination on your first step. Makes it just a little bit shorter, but if you're missing a variable, it's not a bad thing. It actually shortens the problem up a little bit. Or could, if you elect to use it that way. Again, you did not, which was fine. Nothing, no problem happened because of ignoring that, but you didn't save any time, which, depending on how busy we are, could be a bonus or not really something even we want to worry about. That feel okay? How are these three variable systems coming in general, folks? They're getting better. Do we feel like we at least know what the steps are, and if sometimes we make some arithmetic errors along the way and that gets confusing, but at least I know in general what I'm supposed to be doing? Okay. So I would say in general, on a problem like number 2, if you did the steps correctly and you made some, what I would call like a trivial mistake, like you forgot to copy a negative sign down or you added 2 things wrong or something like that, and you ended up with the wrong answers, but you finished the problem. Like you finished the problem, you did the whole thing, and you got 3 answers, and you wrote down like, I know these answers are wrong, I know there's a mistake in here, but I couldn't find it. And you just moved on because it's a time test and you can't spend 2 hours doing one problem. That's probably to me like a 9 out of 10 on a problem like that. So even though all the parts of the answer might be wrong, if they're wrong for just like one trivial reason, it's probably like a 9 out of 10 on a problem like that. Again, I'm most concerned with the process. So if I can follow your work and your work is clear, and it's easy for me to see like, oh, I see it right there. You did 3 plus 4 is 8 instead of 7, and that's what screwed everything up. That's 9 out of 10. No big deal. Does that make you feel any better? And if there's like a bunch of those mistakes, but the process is mostly right, like maybe that's an 8 out of 10. The big penalties come if you kind of screw up the process. You know what I mean? Like if you do, I'll eliminate the x's from A and B and then the y's from B and C, but that doesn't, that's not going to work. You can't eliminate a different variable from both of them. Like if you do stuff like that, those are the big penalty things because you fundamentally don't understand the process. The other ones, it's like, yeah, I know what to do. I've just made some kind of silly mistake, and I know they're hard to find once I've made it to go back and fix. So I'm pretty lenient on those things when I'm grading, as opposed to like procedural mistakes where it's like, oh, you didn't understand how to solve this system at all, or your work was so jumbled it was hard for me to follow like what you were doing. Does that feel fair? Okay. All right. So if you guys would, can you take out your tablets and open up to the content library? Because we're going to do our homework quiz. Just have to get this thing in here that I need. So it'll just be 1 second, but while you guys are getting that stuff out, I'll get that together.
Do you have anything else that we're learning in this chapter?
Mm-hmm. Yeah, we have one more thing to talk about. We're going to do that today after we're done with this. Let's reput this. All right. So I just synced my notebook. So if you sync yours, you should see this homework quiz 3 popping in at the bottom of the content library here in a moment. You might have to wait a minute to do your sync, or sync more than once, because it's might be taking a minute for mine to come in to yours, but it will come in here eventually in just a minute or two. So you have just these 2 questions. So on the solving the system of equations problem, you can do any method you choose, substitution or elimination or graphing or whatever you want to do is fine. When you finish, you'll export this file as a PDF, and there'll be a Dropbox on PowerSchool called Homework Quiz 3 that you'll put that PDF in. Okay? Holler at me if you get stuck or if you can't remember how to do something with the technology or any of that kind of stuff. I'm happy to help. But we'll take some minutes here and let you guys worry about that. And probably the test the end of next week or maybe the beginning of the week after, we'll just kind of see how that plays out. But this is the last piece of new content for Chapter 3. So the idea here is we're going to do some story problem situations where we're going to have to write our own system of equations and solve them. And what we're looking at right now is the assignment that I have for you guys concerning this. We'll do a couple of these just together. because there's no real new skill here. It's just kind of getting comfortable interpreting words and turning them into symbols. Because it's the solving the systems we know how to do, right? Ideally. But nothing new is going to change there. The new skill is like being able to read a story problem and turn it into an equation or a set of equations. Is that okay? All right. So we're going to, I think there's 12 of these total. We'll do the first couple, the first 2 or 3 here together. And I'm going to not do the solving part since that's something that we should ideally be familiar with already. I'm just going to worry about setting things up and getting the system from the words, which I think is probably the new skill that we would be the least comfortable with. Is that okay? All right. So question 1 says that the school Lisa goes to is selling tickets to the annual talent show. On the first day of ticket sales, the school sold 4 senior citizen tickets and 5 student tickets for a total of $102. The school took in $126 on the second day by selling 7 senior citizen tickets and 5 student tickets. What is the price each of 1 senior citizen ticket and 1 student ticket? So when doing a problem like this, the first thing I want to do is figure out what it is that I'm looking for and assign that quantity a variable name. So in this question, the last sentence kind of describes what we're looking for, right? It's the price of 1 senior citizen ticket and also the price of 1 student ticket. So we're asking for 2 different things. We're going to use 2 different variable names, one for each of them. Typically, when I would do this, I would want to name give the variables something that's intuitive, so it's easy for me to remember which one is which. But since we have senior citizen, we have student, they both start with S. I wouldn't want to do, like it's hard to pick the same letter, or like capital S and lowercase s seems like a bad idea. So I'm just going to do X and Y. So X is the cost of a senior citizen ticket, and Y is the cost of a student ticket. Everybody okay there? Since we have 2 variables, we know our system is going to need 2 equations. If I read through this, though, it very much sounded like there was information for 2 separate situations, right? Each of these separate situations is going to represent one of our equations. So the first situation was on the first day of ticket sales. We sold 4 senior citizen tickets and 5 student tickets for a total of $102. How would I write that into an equation using the variables X and Y? Wonderful. 4x plus 5y equals 102. Right? If we sold 4 student tickets at X dollars a piece and 5 senior citizen tickets at Y dollars a piece, the total from that should be 102. Everybody's okay with that idea? Okay. So the second day, we brought in $126 by selling 7 senior citizen tickets and 5 student tickets. So what equation would we write there? Yeah. You guys all kind of talked over yourselves in getting there, but that's correct. 7x plus 5y equals 126. Now you still need to solve this, but the setup is done, right? From there you could use substitution or elimination, or you could use graphing if you wanted to. But that part is done. Everybody feel okay with that first kind of problem? Okay. Let's look at number 2, which is a little bit, I think, a little bit trickier because it's we have to kind of think about it a little bit. So it says, flying with the wind, a plane went 183 kilometers per hour. Flying into the same wind, the plane only went 141 kilometers per hour. Find the speed of the plane in still air and the speed of the wind. Okay, so again, first thing I'd want to do is figure out what it's looking for and assign those quantities a variable name. So one of the things it's looking for, it says find the speed of the plane. So I'll use the variable p for the speed of the plane, and the speed of the wind. So we'll do w for the speed of the wind. Everybody's okay with that idea? So again, I like to name my variables to help me remind what quantity they represent when possible. So P and W for plane and wind. So a common sense question here before we start writing our equation is, what does it mean when we say with the wind? Right? It says the plane flying with the wind, yada, yada, yada. What does that mean if we say with the wind?
Going in the same direction.
Right. So if you say like you were out running and you're running with the wind, what would that feel like?
Might go fast.
You'd probably go faster because the wind is like pushing you along, right? Everybody agree with that? So how would we take that idea of flying with the wind and turn that into an equation? So flying with the wind, the plane went 183 kilometers per hour. Well, we certainly will say that it's going to equal 183, right? Whatever's going on before that. Hopefully that part at least is clear, right? So if the wind is making you go faster when you're running, it's also going to make the plane go faster when it's flying, right? Fair to assume that? So what operation would be going on between those speeds? Addition, subtraction, multiplication, division? Would be addition, right? So we'll just say P plus W equals 183. Right? Whatever the wind is doing is helping push the plane along by the same amount that the wind is blowing. That seems like that makes sense if we think about what's going on there, right? It then says flying into the same wind, the plane only went 141 kilometers per hour. So flying into the wind, what does that feel like? Yeah, the wind is pushing you back, so it's subtraction. It's taking away from your speed. So your system would look like that.
We solve this system, right?
Yep, yeah, so you still need to solve these, but we'll do the setup for a couple of these together just to help get a feel for what we're doing. Do we feel so far so good? Again, this shouldn't be too difficult, but it's a skill that maybe we don't get a lot of practice at. So I wanted to make sure we do some together before I just expect you to do this all by yourself. The last example we'll do is 3. So it says Castell and Gabriella are selling pies for a school fundraiser. Customers can buy apple pies and lemon meringue pies. Castell sold 6 apple pies and 4 lemon meringue pies for a total of $80. Gabriella sold 6 apple pies and 5 lemon meringue pies for a total of $94. What is the cost each of 1 apple pie and 1 lemon meringue pie? So here again, we're looking for 2 things, right? So I'm going to use A as the cost per apple pie, and I'll use L as the cost per lemon meringue pie. And when I wrote my variable for L, you'll notice I used like the cursive L. I tried to stay away from like the lowercase print L because it looks too much like the number 1. So I made sure to write it, the L as a cursive L, so I could tell the difference. Everybody okay with that reasoning? Again, you could use X or Y or A or B or whatever letters you wanted. It doesn't matter. That's what I like to do. Okay. So hopefully when we read this, it seemed pretty obvious that there were 2 separate situations here described, right? The first situation here was what Castell did. So what equation can we write here for what Castell did? Yeah, perfect. 6a plus 4l equals 8. And then our second situation is for what Gabriella did. What would we say there? Yeah. Does this feel okay, guys? So this is your last homework assignment. Well, we'll have the review, but this is the last like non-review homework assignment here for chapter 3, unless we come back and are like, we need some more practice with such and such and such and such after we do the review, and it's fine if we need to go back and do that. But that's it.